This is CyberBrief. Imagine you log into your bank account. You enter your password, pass the two-factor check, everything looks normal. Then you close the tab and go about your day. But somewhere out there, an attacker is already inside your account, and they never needed your password. They never guessed it, never reset it, never phished you for it. They just walked in. How is that even possible? And more importantly, could it happen to you right now on a tab you have open? Here is why this matters in a very real, practical way. When you log into almost any website, your email, your social media, your bank, your work tools, that site needs a way to remember you from one click to the next. The web, by design, has no memory. Every time you load a new page, the server has no idea who you are unless something proves your identity. That proof travels with you in your browser as a tiny piece of data. If someone steals that data, they do not need to know a single thing about you. Not your name, not your password, not your security questions. They just present that stolen proof and the server opens the door. You could be locked out of your own account, your messages read, your information changed, purchases made in your name, all while you are completely unaware. The attacker does not even have to be on the same network as you. They could be on the other side of the world. Now here is the assumption that gets so many people into trouble. Most of us believe that as long as our password is strong and secret, our accounts are safe. Change your password regularly, use a password manager, never reuse credentials. You have probably heard all of that advice. And it is good advice. But here is the uncomfortable truth. Once you are already logged in, your password is almost irrelevant. The thing protecting your session is not your password anymore. It is a completely different mechanism, one most people have never thought about, one that lives quietly in your browser right now. Attackers know this. That is exactly why they go after it instead. Let me give you an analogy that will make everything click. Think about a concert venue. When you arrive, you show your ID and your ticket at the door. That is your password and login. The staff check everything carefully, and then they stamp your hand. From that moment on, you do not show your ID again every time you want to use the bathroom or buy a drink. You just show the stamp. The stamp is the proof that you already went through the proper check. Now imagine someone could take a perfect copy of that stamp and press it onto their own hand. They never bought a ticket, never showed ID. But to every staff member inside the venue, they look completely legitimate. They have the stamp. That stamp. That is exactly what a session cookie is. And the moment someone copies it, they are inside with all your privileges, and no one at the door is any wiser. So let us walk through exactly how this works under the hood. When you type your password and hit login, the server checks your credentials. If they match, the server does not just say, "Okay, come in." It creates a special token, a unique random string of characters, and sends it back to your browser. Your browser stores this as a cookie, a small file sitting in your browser's memory. From now on, every single request your browser makes to that site automatically includes this cookie. The server sees the token, recognizes it, says, "Ah yes, that is the logged-in user." You never have to type your password again during that session. Now here is where things get dangerous. Cookies can be stolen through two main routes described in security research. The first is called cross-site scripting. This is when an attacker manages to inject malicious code, tiny snippets of JavaScript, into a web page you visit. That code runs silently in your browser and reads your cookies, then sends them off to the attacker. You see nothing unusual. The page looks completely normal. Think of it like a pickpocket who hides a tiny camera in a shop to photograph your concert stamp. You are browsing the shelves. The second route is malware, malicious software already installed on your device that has access to your browser's stored data and can harvest cookies directly. Once the attacker has your session cookie, they can replay it. That is the technical term. And it means exactly what it sounds like. They play it back to the server as if they are you. The server has no way to know the difference. Fortunately, there are defenses built into modern web technology. 3 specific flags can be added to a cookie by the website's developers. The first is called HttpOnly. This flag tells your browser, do not let any JavaScript code on the page access this cookie. It makes the cross-site scripting attack much harder because even if malicious code runs in your browser, it cannot reach the cookie. The second flag is secure. This one means the cookie can only be sent over an encrypted connection, HTTPS. If a connection is not encrypted, the cookie stays put. This protects you on networks where someone might be eavesdropping on traffic. The third flag is SameSite. This controls whether your browser will send the cookie along with requests that come from other websites. It is a defense against a class of attack where a malicious site tricks your browser into sending your cookie to a legitimate site without your knowledge. These flags are not automatic. A developer has to consciously add them. When they are missing, that cookie is far more exposed than it needs to be. Let us come back to that scenario from the opening and make it concrete and illustrative so you can see exactly how the pieces fit together. Picture this. Someone is browsing a popular community forum, a site where users can post comments and share links. The forum has a vulnerability. It does not properly sanitize what users type into comment boxes, which means someone can write a comment that contains JavaScript code instead of regular text. An attacker posts a comment with hidden malicious code embedded in it. Now, every user who loads that page, without clicking anything, without doing anything wrong, runs that code in their browser. The code does one thing. It reads the session cookie for the forum and sends it silently to a server the attacker controls. The attacker now has a copy of your stamp. They open their own browser, paste in your session cookie using simple developer tools that are built into every modern browser, and reload the forum. The server sees the valid cookie. It thinks the attacker is you. They have full access to your account, your private messages, your account settings, your posting history. And here's the detail that makes this so unsettling. You are still logged in on your side. Nothing looks wrong. There is no alert, no warning, no suspicious login notification, because from the server's perspective, no new login happened. The session was just used from a different location. If that forum had set the HttpOnly flag on its session cookie, the JavaScript code the attacker injected could not have read the cookie at all. The attack would have been stopped dead. The stamp would have been in a locked box that the pickpocket's camera could not reach. That is the loop we opened at the start. Closed. The password was never the target. The session was. Here's the one idea worth carrying with you. Logging in creates something more valuable than your password. It only lives as long as your session. A session cookie is a temporary key that grants access without any further verification. It can be stolen without anyone touching your password, and it can be used to impersonate you completely. The defenses, HttpOnly, secure, and SameSite flags exist. They have to be deliberately implemented by the people building the sites you use. You cannot set them yourself. What you can do is understand that on any shared device, any untrusted network, any site that feels even slightly off, that invisible stamp on your wrist is the thing worth protecting. Logging out, especially on devices you do not own, is not just a formality. It destroys the cookie. It tears up the stamp. The key stops working. If this changed how you think about what is actually happening when you log into a website, hit subscribe, because we are just getting started. Next episode, we are pulling back the curtain on something most people use every single day and think is protecting them. It is actually one of the most misunderstood tools in security. You probably have it running right now. See you there. Cyber threats don't wait. Neither should you. Subscribe.